let's delve into the whole topic of acid-base chemistry. So let's just start out by defining what acids and bases are. Now there are a couple of different definitions that you can use to categorize or define acids and bases. We are only going to be using what's called the Bronsted-Lowry definition. You don't have to know about who Bronsted or Lowry or anything about that is. You don't even have to know how to spell it. All I want you to be able to do is tell me what an acid is according to the Bronsted-Lowry theory. So, acids are any substance that can donate an H plus ion. H plus is sometimes referred to as a proton. If you remember from the first day of class, we talked about the atomic theory. If this is the atom of hydrogen, in its nucleus there's only one proton. There are no neutrons. In the electron cloud there's one electron. If you have an H plus ion, you're taking away that electron, so you're only left with a proton. And that's why sometimes you'll see H plus referred to as a proton. Acids then are proton donors. Now when you hear the word proton, I want you to think H plus. H plus equals proton. Proton equals H plus. Okay, bases on the other hand are proton acceptors. Anything that can take on an H plus ion is considered a base. Okay, let's talk about the reactions between acids and bases. Acid-base reactions are double displacement reactions. That means that we're going to predict products exactly the same way that we did for those precipitation reactions. Remember when you were doing the outside and then the inside? We'll be doing the same thing for acid-base reactions. Okay, so this is a real problem from your homework, number 37. Predict the products. So we'll have the outside and then the inside. Let's do the outsides first. We have potassium and sulfate. SO4 has a 2- charge. K has a +1 charge. Those are the outsides. Now let's do the insides. We have HOH. What is HOH? That's water. So instead of writing HOH, I want you to write H2O. Okay, now just like we did for for predicting the products of precipitation reactions, we have to go back and balance the equation. Let's start with the K's. We need a 2 here. And then we need a 2 here. Now, the thing to note about all of these acid-base reactions is that they all have something in common. They all produce water as one of the 2 products. The other product is always called the same thing. It's called a salt. This is called a salt. A salt is another fancy word for an ionic compound. We talked about this, I think, in week 2. So, if I were to ask you a question like, what 2 products are always produced in an acid-base reaction? The correct answer would be water and a salt. Let's do another example from your homework. This is number 39. Predict the products, pause it for me and then come back to see if you have the right answer. Don't forget that PO4 has that -3 charge. Okay. That's how you predict products. Now let's talk a little bit about something that we call conjugate pairs. So you might have heard that word conjugate or conjugal before, and usually it's in reference to a conjugal visit. It means that you get to meet with your mate for a little bit. Well, conjugate pairs involve an acid and a base with the same base group. Every base has a conjugate acid, and every acid has a conjugate base. Let's talk about some examples to show you what I mean. Okay, the way you write a conjugate base for an acid is by removing its H. Remember when we first started, we just defined acids as being able to give up an H or being an H plus donor? Well, when you're writing your conjugate base, that's exactly what you're doing. You're just going to lose the H. This A minus is your conjugate base. Now we're going to be doing two things here. The first one is to take off the H, and the second one is to lower the charge by 1. We're taking away that plus charge, therefore our total charge on our molecule must decrease by 1. Okay, so HCl minus the H plus is going to give me an answer of Cl minus. Okay, now look back up here at this example, or at the definition here. Minus 1H. Here, H2SO4 is sulfuric acid. That's what we call a diprotic acid. 2 protons, 2 H's. It has 2 to give, but the correct conjugate base for H2SO4 is the compound that only has one of those H's being given up. So minus 1H plus is going to give me HSO4, and then because my charge is 0, subtract 1, you get a 1 minus. Let's look at the next example. Here we have HSO4 minus, that's this compound. If we subtract 1 more H plus, we're going to get SO4, because now this H is gone. And then we already have a minus 1 charge here. Decrease that by 1 more, 2 minus. Okay, I want you to do these, pause it, and then see if you get the right answer. Okay, if you messed up on these, go back through and work to find where you're going wrong. Okay, let's talk about bases and conjugate acids. Here we are doing basically the exact opposite. So we're going to take a base, B, we're going to add 1 H plus to form HB plus. We have to add the 1 plus charge then. Okay, so here we're taking OH minus, we're going to add 1H plus. So then we're going to get, and remember you always write the plus first, HOH, which is water. How come that's a 0? How come there's no charge there? I have a 1 minus here. 1 minus plus 1 is 0. Okay, let's do the same thing here. Plus 1 more. And this is a sort of an exception to the H comes first rule. You should keep the H's together. So you have NH4 plus. Excuse me, this is the exception, so don't get bogged down on when do I know when to put it in the front or at the end. This is the one exception, so don't worry about that. This is also on your polyatomic ion sheet. That's the ammonium ion. You'll find that on the left-hand side of the pink sheet. Okay, here we're going to have HPO4. 3 minus plus 1 is 2 minus. Then we'll have HSO4 minus and H2SO4. That's all there is to conjugate acid-base pairs. And that brings me to my next point. Water is what we call amphoteric. And that just means that it can be either an acid or a base, depending on what sort of solution or what sort of environment the water is in. So the term amphoteric means acid or base, depending. Water is one of the few things that is amphoteric. So another one of those things that is just great about water. It has so many different unusual properties that most other solvents or liquids don't have. And one of the things that makes life possible. Water is amphoteric.